Oh, okay ya.
Actually, this microphone is for Microsoft team, and somebody at the back, if you cannot hear my voice, you can use something something to hear that they give. So people at the back, can you hear my name and my voice? It's okay. Okay. My name is Dr. Zulfakar Sadi. I'm a postdoctoral researcher from University Technology Malaysia. So I'm also working in the center in UTM, which is Center of Environmental Sustainability and Water Security, IPASA. So the topic today is quite specific on Johor, in Johor River Basin specifically, on climate change scenario and water security in Johor River Basin. So most of the presentation that I will give is most of our finding from our assessment on climate change in Johor River Basin, and also our approach and our solution, mostly on the approach that we use, integrated approach and collaborative approach that actually we can incorporate in the climate change assessment to make assessment, to make our output to be more impactful to the community, to the agency, and to all the people in Johor River Basin. Right. I'm sorry. Wait a minute. Okay. Okay. Just basic understanding of climate. So climate and weather, like Professor Nura explained just now. Actually, sometimes you need to go to the basic to make some people understand what is climate itself actually. When we talk about climate, we usually see the rainfall, the temperature, daily temperature. What it means is that when we see today temperature, or maybe we want to predict what is the weather tomorrow or next week, that is actually weather, where we can predict based on days or weeks. The word that we use is predict for weather. But when it comes to climate, it's more than 30 years. We need observation that is more than 30 years. That is climate. For weather, just now it's just days, weeks, and the best prediction that they can use is up to maybe 1 month, and that is also very difficult. But climate is more than 30 years. It's more than 30 years, and that's why it's very difficult to explain, to observe the climate. When we want to change, to make assessment on climate change, it's quite difficult because the data we need more than 30 years. And sometimes over the years, the change might be caused by climate variability or climate change. Some argue that climate change is caused by, there is not climate change, they said. It's actually because of climate variability. Because sometimes there is ENSO, there is La Nina, climate variability, that is not climate change. But the observation from more than 30 years, a lot of people, scientists, engineers have found that actually it's not just because of climate variability, it's also caused by climate change. Climate change is an anthropogenic effect. It's caused by action by humans that cause climate to change. That's one I will try to explain later. And because it require more than 30 years of data availability and data quality is quite difficult to get. That's why climate change assessment can be kind of challenging. But recent time we have a lot of data also. We have satellite data, we data, we analysis data, simulation data. So the data itself is actually not quite a problem right now. And then there is uncertainty in the model because we want to simulate a climate change. We need a global model. It's like one Earth we need to model. So uncertainty is quite high. It's quite difficult, but the model is improving over time. We have AR5. AR3, AR4, AR5, now we have AR6, we have CMIP6 model right now. When we compare with the previous model, the projection is improving actually. And then when we want to see what actually changing because of climate change, ecosystem response that we need to monitor also need quite a long time. Sometimes we don't know what happened to the trees, the migration of the birds, the changing of the land use. Is it because of climate change or is it because of human activity? So it's some kind of response from the climate change also require long-term monitoring and some kind of big investment. So there is economic and society factor that we want to incorporate in climate change so that we can know what is the scenario in the future. Because scenario in the future is not just about increasing temperature or decreasing temperature, it's about the scenario that they made in climate change is based on the policy, based on the population, based on economic factor. All of these factor is they put into the model to project the scenario in the future. And then there is acute and chronic impact of climate change that we need to measure. When we talk about just 2 days ago, it's also in here. Some people are talking about this acute and chronic impact of climate. Like we have extreme rainfall, that is acute impact of climate. But we have sometimes chronic impact like drought happen for a long time, and the impact we can see observe over time. And the chronic impact is become actually more severe compared to acute impact like sudden increase of rainfall and flood and something like that. That we know it happen, but chronic impact is a long time, so it's require a long time planning, and political system keep changing, and the policy might change, so it's become difficult to handle to deal with the chronic impact of climate change. So just a little bit basic also on global warming. Some global warming is caused by these gases, the culprit here, the usual suspect, methane, we have carbon dioxide, we have nitric oxide, CFC, HFC, and even H2O, water vapor. Water vapor can also cause climate change because the water vapor in our atmosphere, even right now, because humidity is very high, you feel very hot, right? That is also causing climate change, water vapor, increasing water vapor. Because if the world become warming more, there is more water vapor will be evaporated, and it will cause condition to be more humid and hot. So because of this climate change, because of this usual suspect, CO2 and methane, everything, the problem is not that the gases this gas, the problem is it stay in the atmosphere for a long time. It can be up to 300 to 1,000 years. That is the issue, the problem with these gases. It stay for a long time. If it not stay for a long time, then it's not a problem. Because it stay for a long time, then it's a problem. Because it keep accumulating in the atmosphere, it keep trapping the heat, and it cause global warming. So we have some people argue that, yeah, is it the carbon come from climate variety like volcanic activity? It cause carbon to release naturally actually to the atmosphere. So actually from the volcanic activity, we have for carbon, we have different type of carbon. We in science class in our high school we learned that all carbon, all this have a lifetime. So from C14 it will become C13, and then it become more stable C12. So C12 is more stable. So usually from volcanic activity we have C13. C13 volcanic activity. After a few or 3 years, and then it will become more stable, it will convert to C12. But we know that human activity is causing global warming is because there is more C12 compared to C13. Usually, naturally C12 and C13 oscillation is more or less stable in the atmosphere. But because of there is more C12, then we need to ask, where does this C12 come from? And then we understand that after investigating climate change, investigate that C12 is come from the hydrocarbon that is already stable in the fossil fuel gas, petroleum is become stable, and then we release it into the atmosphere. So there is more C12. So it's not naturally come from volcanic activity. So we know that C12 come from human activity, come from the car that we use, combustion and so on. So there's we can, if people ask something like that, maybe you can use this argument that to show clearly that global warming is caused by human activity. This carbon dioxide accumulates more in the atmosphere because of the human activity, that all the stable carbon in the soil, in the earth, has been released because of the human activity. So all these gases now, it causes global warming. So the world become more hot than it's supposed to be. This is the data from NASA, from NOAA. They show that over the years that indeed when the CO2 is increasing in the atmosphere, so temperature also increasing. The correlation is very obvious over there. So because of global warming, it will cause climate change. A lot of people confuse between global warming and climate change. So global warming, it will cause the temperature to increase. Because of this temperature increase, because there is more carbon dioxide causing temperature to increase, it will cause climate to change. So that is the relationship between global warming and climate change. It is not the same thing. So because of global warming, it causing the climate to change. So for example, we have a lot of parameters that we measure. If the global warming causes climate change, sometimes we measure temperature, sometimes we measure rainfall, sometimes we measure wind speed, and so on, so that we understand what is changing in the climate. So the climate, it can change either positive or negative. A lot of people think that climate change causing disaster and so on, but actually some areas that have climate change, like in Russia, because of permafrost is melting, there is more water, there is more land for agriculture. So there is something that positive for Russia. For some areas in Africa, they have received more water because of climate change. So it's good for them, for water availability, for agriculture. But most of the time, because of climate change, the negative consequences happen. Rainfall become more extreme, droughts become prolonged. We even have new term, we call it flash drought right now, not just drought. Drought that happen very acute at certain weeks, that causing because like plantation, this tumbuhan, they have certain threshold of temperature. Animal, they have certain threshold of temperature, and so if it more beyond the threshold, the normal threshold for maybe 2 or 3 weeks, then it can be dying. So consequences for this plantation. So some of the negative consequences, like we have increasing temperature, alter rainfall pattern, like in Johor. Even through observation, we can see that rainfall is become more sporadic. Sometimes in the middle of the years, there's supposed to be a dry season. There is very extreme rainfall, and it's not just extreme rainfall, more rainfall, but that rainfall also causes flash flood. When we look at the data, suddenly I see that usually rainfall causing flood is during the monsoon, at the end of the year or in the beginning of the year during the northeast monsoon. But when I see the record from 2016, 15, something like that, there is more rainfall in the middle of the year, and it's also causing flood. So that is a big concern there. Rainfall become more sporadic. The farmer, the people that go to the sea also become difficult to predict when they want to go to the sea to catch the fish, and when they need to farm, it's become problematic. So there is monsoon sea level rise. If coupled with extreme weather, it will cause more severe flood. So increased humidity, extreme weather, heat wave. Heat wave, never heard about heat wave in Malaysia. Suddenly in 2016, only start in 2016, we have definition for heat wave. In the past, we don't know about heat wave. So we see that emerging threats because of climate change is become more visible for all of us to see. Sorry. Next. Okay. So when we talk about climate scenario, there's some confusion when we talk about climate scenarios. Most of people think that climate scenario is because of global warming. They think that there is more, the scenario that is historically increasing, and then they think that scenario is when it's high because of global warming. But climate change scenario is actually they make it projection based on the scenario, which is what will happen in the future if I go to school or if I don't go to school, for example. Do I go to the university or do I will not go to the university? There is another factor that they use to make future climate projection. So climate projection, they have many scenarios. Some scenario there is low population, so there might be more modest scenario, maybe SSP 3.7, or the worst scenario, maybe population is increasing, more emission because of population increasing, there will be scenario SSP 5, or maybe there is technology transfer, there is technology transfer also helping, it will mitigate climate change. There is a lot of solution, a lot of innovation. Maybe in 2050 it will cause scenario to be decreasing. So all of this factor is actually incorporated into the climate scenario. It's not simply climate rainfall or something like that. So all this parameter is needed to make a projection. The policy of the government, what is the policy? Is it policy for 2050, 2030, or until 2200, 2100? So all of this is needed to make a more robust projection of climate change. That's why we over this event we see some people talking about transition of energy, renewable energy, adaptation. All this factor is actually incorporated into climate change scenario. They have a lot of scenario here. We have the worst one is SSP 5, and the good one is SSP 1. So when we look at this climate change scenario, actually even if we able to mitigate, reduce zero emission under SSP 1, even under SSP 1, if most of the scenario, it will show you that after 2050, it will not decreasing. It will become stable. It becomes stable first. If we reduce the carbon in the atmosphere, because the carbon in the atmosphere is stay for 300 years, 100 years, and 1,000 years. And if we able to have a zero emission, even the best scenario, it will stay linear. And then maybe 2100, it will start to reduce. So what we are doing is actually for future generation, for our children, so to have, people call it intergenerational justice in terms of climate. So that what we do today will determine how they will live in the future. Okay, when we want to do this climate change assessment, we need to determine what kind of boundary level that we want to use. We have regional level, we have such as Southeast Asia or maritime continent. We want to, there is an advantage and disadvantage on how we want to do assessment on climate change scenario. If we want to do Southeast Asia, it is good. If we want to have a broader and holistic view of climate impact on a specific region, one big region, this is enable development of regional policies, and we can compare between region what is happening between the regions. But the bad thing is that this region can be diverse, and the data can be variable. It's difficult to tell this area is increasing temperature or not. Some area have lower increasing, some area have even higher increasing. So it's data variability is there, especially in the tropical country. And then there is a scale issue. It's very big. It's not the scale. Maybe only this one is like 0.5 degree. Or what we need is higher resolution data for country, for basin scale, something like that. So there is a scale issue in terms of regional approach. So and then we have also country approach. When we do a boundary for the country, we have this. When we make this assessment, climate change assessment, it's good for national policy. It's good politically relevant, and resource allocation between area in the country is also can be done. And then, but the bad thing is that the political boundary, the country boundary is man-made. It's not natural. It's man-made. The law of nature doesn't follow what we define. Like if the rain comes because of pulses, because of El Nino, it's come from Pacific Ocean. It's not come from Malaysia or something like that. So political boundary is not natural unit. It doesn't explain how the world works. And there is still lack of detail. Even though we go to county level, there is a transboundary issue. Sometimes we have pollution from other country go to Malaysia. How we are going to handle that one? Some issues, something like this, it's become quite difficult to address. Even though we have some solution in our country, but transboundary issue is still there. And then we have basin level. So this basin level is what we are doing for Johor River Basin. We like it because it's a natural unit. Then we consider the natural boundary. So this is natural boundary is like the nature itself tell you how the world works, how the water flows. So we know hydrological insights in the basin. We know which basin is there, where the water flow, and the hydrological unit. We understand what is the soil there, and then it's good. There's an ecosystem connection. What happened upstream will cause impact to downstream, and what happened in downstream can maybe mitigate impact because of extreme weather in the upstream. So there is an ecosystem connection there. We can make a relationship there. And then the data is also meaningful because we use the data and it directly translates to what happened in the basin. And then we can customize solution to address the issue in the basin. And then the best thing is that we can do community engagement directly because the basin is small. Whatever happens in the basin impact the community. So we can easily identify which community we want to address, we want to engage, to explore the solution or to make experiment together and so on. But there's some disadvantage also. There's a complex interaction even though it is in the basin scale. And then there's a limited scope because it's small. But we take more on the advantage of this basin scale because there are a lot of issues can be addressed. More impactful research we can do. Like that is how our project come into being. We are under water security hub in Johor River Basin. So we have this define our study area in Johor River Basin. So we map everything, what is happening in the basin here. So where is the pollution sources, where is the water come from, where is the community. We map everything so that we can make a connection between all actors in the river basin. So it's easy to understand how climate change will impact everyone in the river basin. So other than that, in GCRF, in this project, we approach this issue through the collaboratory approach and integrated approach. So to collaboratory approach, we have our partner also from Colombia, from India and Ethiopia. So they have different problems that we can learn. Like from the Colombia, they are very strong on ecological justice, community engagement, something that we learn a lot from them to engage the community. And we have in Ethiopia about water quality, problem scape, and a lot of new definition jargon and something like that we learn, we share together. So this collaborative approach kind of develop how we try to address water security in Johor River Basin. And then we have this water security hub in Malaysia, in Johor River Basin. We have integrated approach also. We are not working in silo. I'm not working by myself on climate change. We have some people working on water quality, some people working in value mostly working with the community, how to approach the community, I don't know. If I cannot do it by myself, then I need their expertise on that one. We collaborate together and we learn together, and then our team is working in governance and some people working in health. Because if we don't have this team that working with community, working with the government, I can make a lot of mapping, 415 mapping, a lot of analysis, but how to relay this information to the government, to the community will be quite challenging unless we work in the integrated approach. So I will just show you some of the findings that we find from climate change scenario in Johor River Basin. First, climate change scenario, actually we can we can assess it based on the historical assessment and future projection. So actually, historical data that we have, we can assess it. We can kind of see the trend there. Is it extreme rainfall or increasing or not, or something like that. And we have also based on historical assessment, we can make future projection. Because if we can predict the future, we can model the historical, then that model we can use to predict the future. So we can do historical assessment and future projection to understand how the climate change in Johor River Basin. For example, we do a historical assessment for extreme rainfall. Some of the research that we do, we already published. So for example, we have rainy days. This is the same thing with all our observation actually in Johor. There is more there than is rain. More rainy days. Even in the middle of the years. That means if we look at this data, that means that the rainfall is become more sporadic over the years. The increasing there with rainfall is there. It's good if in terms of water availability, but it can of bad in terms of floods and something like that. It become concern for erosion and something like that. And then we have rainfall concentration. We understand, we know where rainfall is mostly concentrated. We see that in Johor River Basin, we see that rainfall is mostly concentrated in Sayong River up there. But over the year, by using a train assessment, Mankendal, we find that more rainfall are increasing at the east side of the river basin. So it's quite a concern. It's good for water in the dam here, in the Lingyu Dam, but it's not very good for Kota Tinggi because there is more rainfall is concentrated in Kota Tinggi. We know Kota Tinggi is a very vulnerable area for flood, so that it can be a concern there. And then we have do some other indicator on extreme rainfall. Heavy rainfall is increasing mostly in also in area Kota Tinggi here, and most upstream area in the middle part of the basin is increasing. And then we have very heavy rainfall, up to 20 millimeter rainfall per day. Also the same pattern that shows significant increasing trend. So when we see this result, we see that the threshold, based on the threshold, 10 millimeter rainfall, 20 millimeter rainfall, and 25 millimeter rainfall is show more significant change in terms of increasing rainfall. But when we look at the quantile, there is no significant change. So it's not very relevant. So I believe that in Malaysia, we need the indicator that we need to use to measure the rainfall. Is it causing flood or not? I think it's also incorporated by DID and Meteorological Department. They have their own definition for awareness, critical level or something like that. They use threshold. So I think that is a good way to measure how the rainfall is increasing or not. In Malaysia, we use a threshold method. It's quite good. It's quite the response can be done very well when the flood happens. It's the same with heat wave. We also have threshold that we use to identify is it level 1, level 2, or level 3 of heat wave or something like that. So threshold method is very good to help us to understand how climate is changing in Johor River Basin. So and then we do a future projection based on the historical data that we use. We make a statistical downscaling using a CMIP6 model. So some of the paper have been published. So we have made a projection with, for the near future and the far future. Because climate is 30 years, right? It's more than 30. We need to make a projection based on 30 years and 30 years. So we usually in climate scientists, we slice the future projection maybe into 3 or 2, something like that. Because of the CMIP6, it starts from 2020, we only able to slice it into 2. From 2021 to 2060 and 2061 to 2100. So we have projection for near future and projection for far future. So it's the same thing happen. We more rainfall in Lingyu Dam and more rainfall in Ulu Tiram and Kota Tinggi area here. For under different scenario, just now is one SSP1, this is scenario 2. The projection is quite similar because the area is quite small, and the highest projection is the worst case scenario is 8.5. But what we see is the difference is the amount of rainfall. We see that the amount of rainfall under different projection is different. For example, in the far future, compared to the near future, in the near future, Johor River Basin up to 2050, 2060, they will have maybe more flood during the northeast monsoon. But in the far future, based on the projection, it shows that there will less rainfall, because we know that there's a process of evaporation, global warming. If it's not mitigated, if the water is evaporated too much, it will not become rainfall. But right now, because temperature is about increasing, temperature is about daily maybe 30, 33, something like that. So it's evaporate very fast and it become rainfall very fast. Also. But once it's reached certain threshold that daily temperature is increasing, it will evaporate. Maybe because it's go to higher place up there, it's because of the wind, it's go to other place. And then in the far future, maybe we have problem with water scarcity, but in the near future, we might have problem with flood. So there's different spectrum, higher rainfall and lower rainfall. And then we make a historical assessment on drought also. Some paper we have published on this one. So we have assessment on drought occurrence. We understand that downstream area of Johor is more susceptible to droughts, but it's good actually because most of the water comes from the upstream, right? But still, it's a concern for urban area. It's become more dry, it's become hot because of droughts. So some area here we have Layang Dam. Here they have dam here. Sometimes because of droughts, it's become prolonged. The water become very low. So this is a concern also. It's happened. It's recorded. There's some water scarcity happen here in this dam. Maybe because the occurrence of drought, it impact mostly on the downstream area. Even when we look at the one-day droughts, 2-day consecutive drought, or 3-day consecutive drought by using SPI, most of the downstream area will be affected. And also in some dam up here that is supply the water to Pengerang area, so susceptible to drought condition. So when we see this result, that there is some dry area, some extremely dry area in the south area, but the projection on rainfall just now is also show that more rainfall, right? So how come it's happened? Something like that. It's because of the monsoon in Malaysia. We have northeast monsoon and southwest monsoon. During the northeast monsoon, it become more water there. More water during the northeast monsoon, extreme rainfall happening become more concentrated in November, December, and January. Previously, it's booked from October, November, but it's now become more concentrated on November, December, and January. It's become flooded. But when it's come to southwest monsoon during the relatively dry season, some area also have affected by water scarcity. And then what we found very interesting on droughts is actually we found that drought is influenced by this global phenomena, large-scale phenomena, which is El Nino, IOD, and MJO. And especially droughts will happen when there is like concurrence event between El Nino or IOD, or maybe MJO with El Nino. The droughts will more or less will happen in Johor River Basin. So El Nino is different. Even very weak El Nino also can cause droughts in Johor River Basin in some part, because El Nino is very strong. Even if very strong El Nino, it's become worse droughts in Johor River Basin, even in some part of Malaysia. But what we found is that this co-occurrence event is we need to monitor. Maybe meteorological department, the ID or NARIM, they need to monitor this event to understand, to predict, to prepare. Is it going to be a drought or not? Based on this event, maybe we can, the data is there, we can use it to understand is the situation become worse or not. And then we have heat wave. So heat wave definition for heat wave in Malaysia, I think start from only 2016, because we never understand heat wave. It's only happen in Europe or something like that, because they have very hot summer or something like that. And our temperature is mostly linear, it's not changing much. But over the years, because of global warming, climate change, heat wave, temperature died. Temperature during the days, maximum temperature is temperature during the days. It's become, sometimes it's come, some station record up to 40 something like that. But most of it, when a heat wave happens, it come up to 35, 36 or 37. So we already have our own monitoring indicator on level 1, level 2 and level 3 heat wave. So if we look heat wave, because it's a big event, so I make a projection for level 1, level 2 and level 3. And we see that TMS is actually increasing every year. So the pattern is there. Every year it's become higher temperature. And then we see temperature is increasing up to 1.25 degree from 1950 to 2021. So the has increasing 1.25, and this is the pattern of maximum temperature. We see that in March, April, May is more susceptible to heat wave. This is the historical one, but now the concern is the projection. When we look at the future projection for heat wave. So when we look at future projection for heat wave, we already know that historical one, the recorded temperature is increasing, obviously, and the worst scenario, it shows that it's overshoot quite high up to 34 and 35 something like that. And this is only the average. I'm not taking the daily one. The average is already 34 something like that. Now, if we look at the monthly one is also increasing. Most of the year of the months is increasing. You can see this is actually a spider web. We can see from 1960 to 2100, the temperature is increasing compared to the historical one. And here, this is the projection for heat wave in Malaysia. So it is expected that our school children will not go to school on March, April and May from 2018, because if it reach level 1 heat wave, the school will close. So our children will have a school holiday during this March, April and May. If the mitigation is not there, this is what will happen. So our children will be happy, but for us we will not be happy because they will not go to school, and it's difficult for people to go to work also during the days, and some type of mitigation and adaptation must be there, maybe to protect our children and then vulnerable communities like older people that is more susceptible to heat wave. And then this is that I showed the monthly scenario just now. So we see that extreme rainfall. This is just the general climate in Johor River Basin. But all the projection just now, it showed that there is extreme rainfall in November, December, and January, especially in December. Now we also already in November. Maybe there is not much rainfall right now because of El Nino. El Nino is like decadal event. It's not monsoonal event. If it happened during the El Nino happened in the middle of the years, then it will become more water scarcity in Johor River Basin. But if La Nina happened in November, it will become worse flooding event in Johor. And then we have heat wave in March, April and May, and then droughts become more prolonged. Usually droughts event happen in May, June, July, August and September. Now it's become prolonged, it's come up to October, and maybe it can start from February. If March here it's become lower rainfall, so it's become prolonged from February until September. But the worst one is during the drought is actually during the August. August, maybe I need to make another assessment on flash drought, that how flash drought happen in August, affect especially the plant and some animal and something and human also. So how actually we did all of this? What we do is we collect data. We have our method, we map the result, and then we identify the hotspot, and then we publish the data. The data actually for climate change, we actually have at this point, maybe in the past 10 or 5 years, we already have too much data. We have satellite data, station data is also there. We have citizen science data, we have grid data, simulation data, global data. There is too much data actually. Satellites keep going to the space. So it's not a problem for climate change assessment anymore. But the problem is how the skill, how to manipulate and how to use the data. that is the concern right now. But we have our method is keep developing in scientific community. We have dynamic downscaling, statistical downscaling, climate change vector, weather generator, and a lot of methods that we use. And then we mapping also. We can use machine learning, ArcGIS, QGIS. QGIS is free. Everyone can do it, but it requires skill. We can use Python, AI, and so on. And we identify the hotspot based on the, people even identify when the flood happened just by algorithm in the Facebook. Somehow they can collect where people say flood or banjir or something like that. They know which area happened with a flood. So all the disaster is recorded officially also. Some community also collect this kind of data, and then we publish the data, the result. But the problem with this method, this approach that we use, not me, everybody can do it with the comfort of our office. So this is my office. I can just sit there and I do all this approach. I can tell everybody how I do it. Really, it's not a concern anymore because everybody can do it. Tutorial is everywhere in YouTube actually. So collect data, methodology, mapping, hotspot, publish it's easy. I can do it. I already published about 30 paper incoming, maybe 45 paper just by sitting at the comfort of my office. So the question is, what do we miss if we keep doing what I am doing? And some of us are doing, most of us are doing actually by using this approach. So we miss the impact of our research. Is it what we do, what we map, the hotspot, the projection that we do, is it impactful for the community or not? So how it can be very useful, how the agency can use what we find. So based on all our research, our finding, what action can be made actually? Is there any action, or we just put all my paper, just publish it, and usually in the dustbin of history, something like that. And then the evidence, there's many types of evidence actually. Some people, they rely too much on science-based evidence, but there is other evidence that maybe we overlook. There is photo, there is storytelling, there is a video, there is music. People make a music out of something that is very bad happen to them. There is a field report. All this evidence that we need to capture somehow. We miss this kind of evidence, either tangible or untangible, if we keep doing what we are doing at the comfort of our office. And justice, where is justice? When we make our research, we tell them this is a flooding area or something. Is it really flood in that area? Sometimes we make a simulation of flood model, right? Oh, this area is flooding. But when we go there, the community said, no, there's not flooding there. But the model said it's flood. No, it's not. Why? There is a plantation there. It's flood or not, nobody cares. So there's paddy field there. It's flooding or not, it's not flood for them. That's actually good for them. So this kind of justice on data, on information is important. Then we have ecological justice right now, environmental justice, community voice. We need to take all the information from all actors in the river basin to understand what is actually happening. Is it the data, so that the data that we have can translate what is qualitative information from the community. We can use it to understand more the data. And then the solution, we have a lot of research. Is there any solution? Is there any innovation? Is there sustainable product is produced from our research? Does our research attract more funding? Or there is research grant that we can use to solve the problem because of climate change? So all of this is missing if we do everything that we do. So how we are going to translate this evidence so that there is more solution, justice, impact, evidence, action, and so on. So one of approach that we use in our research is we need to rethink how our research approach is. We rely too much what we learn in the school, high school, or even in the university on science. I call it science-based approach. We have data collection, methodology, analysis, result, and then impact or mitigation and adaptation action, something like that. But there is another approach actually. We have cooperation approach. This is more community-based, social science. Over time they have developed this approach, which is co-explore, co-design, co-experiment, co-implement, and co-management. It's almost the same like sand-based approach, but all this process, they have their own tools. They have very interesting methods, very interesting tools that we do together with stakeholders. We do it with school children, we do it with community members, we do it with young people, and all actors play a part in the process of co-explore, co-design, co-experiment, and co-implement and co-management, especially co-management. We do a lot of research, who will manage it after that. We do finance adaptation process. There's a lot of adaptation process, and then we left it like that. Who will manage, monitor the adaptation that we propose to the community? So this approach is actually can complement how we do our research. So all this process, the best thing about this co-creation process is that we can do a co-explore, co-design, all this co at any part of the method. Doing the data collection, for example, we can do all of this stuff, all of this approach. For analysis, method, result, and adaptation, we can do all of this approach. For example, I show you why this approach where we do activity together with stakeholders is because the data quality will improve. We know which data that we want. It can enhance the trust between the scientific community with the agency, the community with the agency, the industry with the community, because the process will involve all the community. It will cost savings, ownership and engagement. All the process is owned by everybody that involved. There is locally relevance, diverse perspective, direct data collection on the spot during the stakeholder engagement, focus group discussion, and so on. We can actually get the data over there. And then a lot of innovation and creativity during the process. A lot of new method that we use, a lot of solution actually. Simple solution, sometimes it's simple solution that we can use to solve the problem. So it can, because the innovation comes from maybe community leaders and so on. Okay, so this is some of the methods, some of the tools that we can use. I'm not arranged it properly, but all of this we can use anywhere. Either we can use it doing co-explore, co-design, or co-management, co-experiment. All of these tools, methods, either we use it together or we use it based on your own needs, based on the research question that you want. For example, we do a survey, maybe questionnaire, something like that, just to collect the data. We can do a crowdsource, we can do interview, we can do a headlines. Doing the educational program, we can do a lot of other program, other method that we use to doing the educational program. We have wall of ideas. It's just the community member doing the stakeholder engagement. We put just the question there, and then they put sticky note what they want to answer all the question. We have word cloud and gaming. Sometimes we have all our input, output research, and then how we want to teach the students. Are they going to interest in how the process of learning must be interesting, right? So we introduce in terms of gaming, collect the rubbish in the VR or something like that, to play some games. And then we have citizen science to explore the data, even to implement the data. So it's become more interesting. And then when we want to understand the awareness of the people, we can just put this. Sometimes people, we don't know, to gauge the people awareness on water quality in the area. Are they interesting? Are you aware about your river? That's a simple question. It's very difficult to know what is the answer. So we some during the Love River program, we put some photo there. Do you know what river is this? Some people know what is that river. Some people don't know what is the river, the name of the river. So just by using these tools, this method, it's more interactive. We get the data on the spot, and then we know we can gauge the people awareness level. It's a very simple method, but very interesting one. We can make a roundtable discussion, lineage, something like that, forum dialogues. There's a lot of innovation on this cooperation approach. Very interesting that we are incorporating in this climate change assessment also. Like for example, when we want to collect the data when in the DCI program, and the first stage, we make a stakeholder engagement between our collaborators. We from the collaboratory from India, Ethiopia, and Colombia. We co-explore together what data that we need. So a lot of people are working on graded data. So we experiment the data in terms of the data is good for Johor River Basin or not, something like that, because we need to validate the data, and then we come out with a lot of satellite data, reanalysis data, climate model, remote sensing data, land use data, which is they think that is good. We don't need to do experiment. They already made the experiment, so it's kind of a shortcut for us. And then we have all the data we have. We need somehow output we need to manage. So we come up with Huda and Fleur to co-manage the data and something like that. And then we also make a co-explore process, cooperation process to co-explore with our stakeholder. We identify who is our local stakeholder. We want to collect the data, so we must identify who has the data first. Otherwise, the process will become very long. Sometimes doing the stakeholder engagement, we can explain what is the data for. If we explain properly, the data is for water security, for climate assessment, how we want to access the data, how we want to use the data, and then the people that have the data will know that the data that they have is used for the good of the nation, for their place. So it's build our relationship and trust between stakeholders. So we have station data, and then if we ask the data, if we look at the time series, sometimes the rainfall increasing, rainfall decreasing, something like that. It is just a number. It's just a number. So what, right? So if we do a stakeholder engagement, something like that, we can understand why certain station is located at this place. Why it measure rainfall here? Why some area measure rainfall and there is a siren for flood evacuation, but some area is not there. So by this qualitative information is important also. So it's help us to understand the data. So this is very important because a lot of climate scientists they look at number, but they don't understand the data. To understand the data, we use this cooperation approach. So we also got the field trip with the expert to go to the station. Why there is a lot of other measurement that they do with the station. Why they put the data there and so on. We have the purpose of the data. We use it. Water demand, water quality. So we understand that why they put the station there. Is it for flood monitoring, to monitor rainfall, or for warning? And then we make our research to have a flood early warning system, how we can co-design with the stakeholder or to improve alert with the community leader. And then we also have collect other data. If we go make a stakeholder engagement, focus group discussion, meeting, expert elicitation, we can identify the stakeholder, and we also get other data other than rainfall. We can get flood data, what is the policy for the data, what is the policy after we know flooding is happened, what is the administration system and the program that already there. There is no point if you want to propose some mitigation option, if the agencies already have the same thing. So it's overlap, it's waste of money. So we get a lot of other data also, the benefit of cooperation activity. We also have an educational program where we co-implement with other agencies together, and then we co-explore, co-experiment. We have citizen science data that we make an experiment with other school children. It's a very interesting one, with also a school climate change awareness program. And then a lot of data from science, citizen science data, we get qualitative data. If we rely too much on rainfall data, it only measure one parameter. It only measure rainfall. But if we use citizen science, maybe we can measure, is there lightning during the rainfall? Is there the wind? The wind speed is high or not? Is there cloud cover high or not? That's kind of question that we are asking during citizen science data. Is there rainfall during the morning, afternoon, night? All this information is important. We can understand. Is there rainbow? Something like that. Some people are also interested in rainbow because it's good for tourism. We want to identify which area have more rainfall that have rainbow. So all this qualitative data make our data more meaningful. So all of this approach actually we do doing, for example, we have rainfall for citizen science to collect the data to educational program. We have program Sahabat Air, we have climate change awareness program. We co-implement it with the education department. We're not just training the students, we also together directly or indirectly training the school and also training our postgraduate students so that when we implement this process, everybody will become ambassador for climate change so that they can teach other people and so on. We have co-explore and co-design on flood early warning system. What we understand how we understand more how flood early warning system works in Malaysia, and sometimes we found that communication between the apps that prepared by the agency is not being used. Maybe because of, I don't know, people. We found out that people want to use information through WhatsApp better than using the app. People want to use WhatsApp. Information from WhatsApp is more circulated compared to the apps. And then we have training workshops. We have Love River Johor program. All this program is not just create awareness, it's training the people, and we also do experiment together with the community. So that what we do, experiment that we do, all the things that I do, the mapping that I do is are more impactful to provide a solution for the community. So I think it is all other program that we do. We cannot just say there is climate change, more rainfall, something like that. We do plugging exercise, also tree planting. Over that, we do it time. We not just the university, IPASA or UTM only. We call our agency, let the agency that interested, so that the process, the program can be done together. I think that's all for me. Thank you. You have any question?
Are you open for Q&A? Are you open for Q&A?
Yeah. Any question? Everything's very clear. Okay.
How is your research funded?
Our research is based on the project for this one. We have a Global Challenge Research Fund. It's under the British Council, UKRI, the UKRI. So the fund is actually distributed between 4 collaborators from Malaysia, India, Ethiopia, and Colombia. So all the collaborators have different issues on water security. So the fund is used for tackle all of these problems.
How much is this funding being?
The funding starts from 2019 until we are already at the end of the project, and it will be finished actually for 2 February next year, but it can be extended a little bit until September next year. So it's quite a long project, big project. So a lot more than 100 scientists involved. So a lot of people working on different fields. We learn from each other, even the cooperation process, all the approach to the community, we learn from each other. So that's the thing that we learn. Any more questions?
Actually, I'm under here from BTM as well, but currently attached with BDT. I'm quite interested with your topics right now, because previously I was working with one of the local authorities on looking into Skudai River situation, probably much more on the awareness of students, young students in the school level, that they are towards sayangi sungai kita or not. Okay, so from your point of view, I think you are much more on the technical part. Okay. So what do you think about the importance of having community awareness